Hello everyone. Let's start talk about Section 1 image classification in Google Colab. We'll cover fundamentals of convolutional neural network CNN and introduce keras, and talk in general about a Colab notebook, which includes example, assignment, and solution practice. And I'll take you to look at the code in details. If you are the first time to know these fundamentals of CNN, it's probably hard for you at first, but you're welcome to go back to watch this video again or read the books we suggested in our paper and supporting information. So at first, what is the convolutional neural network or CNN? This definition is adapted from visual cortex. It means many neurons in the visual cortex have a small local receptor fields, meaning they react only to visual stimuli located in limited region of the visual field. If you look at this figure, 5 of the neurons get information from the local receptor fields and process those informations layer by layer and finally know what substance it is in your mind. CNN in machine learning is evolved from this idea. For the first CNN architecture, an important milestone of it was a 1998 paper by Ian et al., which introduced the famous LeNet 5 architecture, widely used to recognize handwritten check numbers. It introduces 2 new building blocks, convolutional layer and a pooling layer. In the later slides, we will need to understand what is the convolutional layers and pooling layers. For convolutional layer, it is the most important building block of a CNN. You can use the math array to represent it. Neurons in first convolutional layer are connected to pixels in receptor fields in input layer, and it concentrates on small, low-level features in the first hidden layer and then assemble them into larger, high-level features in the next hidden layer. In order to understand them well, there are several new definitions in here, like the stride. Look at the figure in the right. So the stride means the shift from one receptor field to the next. In this figure, the stride equals 1. And we have the zero padding. In order for a layer to have the same height and width as the previous layer, it is common to add zeros around the inputs. So in this figure, the shaded area is the zero padding. And we have the filter, or called convolutional kernels. A neuron's weights can be represented as a small image, the size of the receptor fields. So you use that to calculate and get the number of this one. The feature map highlights the area in an image that activates the filter the most, so you will get the most important features in the feature map. For the pooling layer, this image is the example of max pooling layer. How it works is like to get the max number in the receptive fields and get your pooling layer, this number, and move on to continue. The goal of pooling layer is to subsample or shrink the input image in order to reduce the computational load, the memory usage, and the number of the parameters. Another thing to understand is the model compile. So this image shows the whole process. When you input your data, in our case it's the image, and process it layer by layer. This layer like a convolutional layer or max pooling layer. And finally, you will have the predictions y prime. And then you compare this with the true targets that you labeled. You use the loss function to calculate it and get the loss score, and optimize using an optimizer function by updating weights, and then do it again until you get a good performance of your model. And you use the metric, a function that is used to judge the performance of your model. So, how to implement the CNN model, or we call it CNN architecture? We use the keras. Keras is a deep learning API written in Python, running on top of the machine learning platform called TensorFlow. It was developed with the focus on enabling fast experimentation. This figure is the screenshot from Keras website. You can click on Get Started button to read the Keras documentation. And this is the screenshot from our Google Colab notebook, and this example of Keras syntax. And you will see that the CNN architecture are composed of the convolutional layer, pooling layer, and then convolutional layer and pooling layer. And finally, several dense layers. You will have the final predictions. And you can compile the model by giving loss function, optimizer, and matrix. Then we'll talk about our Colab notebook. This example notebook, we will use a dataset called Fashion Amnest dataset, which contains 10 different classes of clothes, and our goal is to classify them using CNN model. The way we do it is we split the dataset into train and test dataset. We use the train dataset to get train model, and then test the performance and make predictions using the test dataset. This is the screenshot from our Colab notebook, and we run this code to make predictions. And then is our assignment and solution notebook. It's about amoeba classification. The goal is to classify if an image contains amoeba or not. All of those amoeba images are collected from our lab. The way to culture this amoeba and how to take it are in our paper and the supporting information. And then the methods to get a trained model and make predictions are the same with the closed classification. The different thing is that our data is not too big, so it involves some methods to make the trained model and the performance stable. And finally, let's look at a Colab notebook in detail.